Hello, and welcome to another episode of Fun with Code. Today we're going to be looking at multi-motors. So we're going to start with all continuous loads. What we have is motor 1, motor 2, motor 3. These are 5, 7.5, and 10 horsepower, 208 volt, 3-phase. Always be aware of the phase, if it's single phase or 3-phase, the voltage, 208, whatever it may be. In this case, we're looking at table 44 because we're dealing with 3-phase motors. So we look at the 208 volt column. For M1, 2, and 3, we'll see that each motor is, so the 5 horsepower is good for 16.7, 7.5 is good for 24.2, and the 10 horsepower is good for 30.8. So in this case, we're going to apply 28106 sub rule 1, and we'll take them all at 125%, which is standard continuous application. So we end up at the end of the day with 20.8, 30.25, and 38.5, which means since the equipment is not marked, we're looking at 4-0062A. We're going to use the 60-degree column for sizing the wire. So we'll end up with and according to table 2, we'll end up with a number 12, number 10, and a number 8. So when we look at the supply conductor, we're looking at 28108 sub rule 1. And here we're going to take the 30.8 amps, which is the largest. Notice we're in the column for the FLCs, the full load currents. We're going to take the largest motor times 1.25. And as the code is instructing us, we will just add the FLCs of the other motors, 24.2, 16.7, which gives us a total of 79.4 amps. So we look at, we can reference 4-004 here, but a straight reference to table 2 is also fine because we've already referenced 4-006 here, so that's okay. So we look at here, we're looking at a number 3 because we're dealing with copper conductors. So now we want to size our time delay fuse, and notice this is a maximum size non-time delay fuse. We're looking at 28204 sub rule 1 is giving us regulation, so we're going to use table 29 for this. And this is where you'll find, because we're using a non-time delay fuse, we're going to multiply this by 3 as indicated in table 29. So under 28204 sub rule 1, it doesn't specifically mention table 29, but it does make a reference to 28200. So that's what we're looking at there. So again, we're going to take, now be aware here as we move on, what we're doing in this case and in other cases is we're actually using the FLCs here. So we take the 30.8 times 3 because we're dealing with a non-time delay fuse. Table 29 is giving us this multiplier plus the 24 plus the 16.7. And again here, notice we're taking the largest motor times 3 and then we're just applying, or then we're adding the currents. Gives us 133.3. And since we're dealing with a fuse, an overcurrent device, we're using 14104.1a, table 13. And we're looking at a 125 amp non-time delay fuse. Why are we not going up? Because this is a maximum what we're looking at here. So we go down to the next size, which gives us 125. Now when we look at the tap conductor size, 28106 sub rule 3, I just want to sort of mention a couple things here. Do not exceed, if it does not exceed 7.5 meters, we take the supply conductor divided by 3 for the ampacity. If it exceeds 7.5 meters, the tap conductor has to be equal to the supply conductor. I also want to make a little side mention here. 28110 sub rule 2A and B is giving us a little bit of regulation on the meters, the distance for the tap conductors. So there's a similarity here, but there's a little more regulation under 28110. But these exercises are designed for 7.5 meter or less installations. So we take the supply conductor, which is a number 3 from the previous example here, the number 3, and it has an ampacity of 85 amps, or according to table 2, so the 60-degree column is what we're looking at. So 85 divided by 3 gives us 28 amps. we look at a number 10, and when we look at this number 10, it meets the ampacity for the 30.8, 24, and 16.7 amps relative to these loads here. So that's the first one. Now we look at where we have these non-continuous loads, where we apply table 27. Same motors, 5, 7.5, and 10, same FLCs, and what we're going to do here, 28106 sub rule 2, because we're dealing with non-continuous loads, we're going to apply the values in table 27. So here NC is non-continuous, PD is periodic duty, we have STD short-term duty, and ID intermittent duty. So what we're going to do in table 27, it's going to give us some instruction here on what to apply. So in this case, we're going to apply 0.9 and then for the first one, so we end up with 15.3, 1.1 for the second gives us 26.6, and 0.85 for the third one. So we're looking at 15 amps, 26, and 26. So we size our conductor accordingly. Equipment not marked, sorry, a little mistake there, but 4-006 2A, not 004. Number 12, number 10, and number 10 is what we end up with. And again, here, my reference, you can reference this, but it's already referenced through 4-006. So there you go, make that correction in there. And again, you can make the reference to 4-004, that's fine. But table 2, number 4, sized according to the 60-degree column. Now here in this case, for the supply conductor, we're applying 28108 sub rule 1B. So notice in the previous question that we applied the FLCs because they were continuous rated. And here, when we deal with the non-continuous rated, we're applying the calculated values. And that's something to be aware of because moving forward, we're going to mix them up a little bit. So for the continuous rating, we use the FLCs. For the non-continuous rating, we use the calculated loads. Only notice we're not taking anything at 1.25. We're just taking the calculated loads, adding them up, gives us 67.8 amps. We'll size the conductor accordingly, so number 4, 60-degree column. So here we're going to have, again, a maximum size time delay fuse, regulated under 28204 sub rule 1, table 29. Now notice here that this code is telling us to use the FLCs. We are not using the calculated values here. So when we size our overcurrent devices, we're always coming back to the FLCs. Here in this case, because it's a time delay fuse, we're going to apply 1.75 according to table 29. So we take 30.8 times the table 29 value, depending on what the OCP is. Plus the 24 plus the 16 gives us 94 amps. Notice I've made a note here that these are the FLCs. So under 14104, we end up with a 90 amp time delay fuse. And again, this is a maximum, so we don't go beyond that. We have to go down to the next size. When we look at the minimum size tap conductor, always remember that when it comes into conductors, we deal with the language of minimum. When we use breakers, typically we're using the language of maximum. You can always go up with the conductor, but you sort of want to stay tight to the load with the breakers or the overcurrent devices. So we're going to take the supply conductor divided by 3. So we're looking at a number 4. That gives us 70 amps. Under the 60-degree column, 70 amps divided by 3 gives us 23.3 when we're looking at a number 10. So it meets the ampacity for the 15, 27, and 26 amp loads. Here we're moving on, and we're going to have a little bit of a combination now. So motor 1, 2, 3, 4, and 5. We have 10, 15, 20, 7.5, and 10 horsepower, all 460 volt, all 3-phase. We're looking at the FLCs for each motor here, 14, 21, 27, 11, and 14. So here for the 3 continuous, we're looking at the FLCs. For the non-continuous, we're going to apply table 27 here. Notice 28106 sub rule 1 and 2 are being applied because we have continuous and non-continuous. So here we're going for the continuous 1.25, 17.5, 26, 33. Size the conductors accordingly. Equipment is not marked, so we're back to 4-006. For the non-continuous, we just apply the calculated value, and this is where we have a combination of the two. So notice the supply conductor is regulated under 28108 sub rule 1C, 1, 2, and 3. So we're looking at 27 times 1.25. Here we're looking at the continuous rated FLCs, okay, 14, 21, and 27. So we take the largest at 1.25 plus the other two, and then when we look at our non-continuous duties, we're going to take the 16.5 and the 16.8. So notice this is a combination of the first two. So we have 102 amps. We look at table 2. We're looking at a number 2. Because the 102 amps here is good for the 75 degree column. Because we're over 100 amps, we need to apply to B under 4-006. So that's how we size that conductor. And we're looking at the minimum size breaker this time, 28204/1, table 29, the 2.5 because we're using a breaker. So we're taking the 27 amps, 2.5, and again we're using all the FLCs. We're not using the calculated values for a total of 127 amps. I'll apply through table 13. So again, this is a max. We're looking at a 125 amp. When we look at the tap conductor, we're going to take the ampacity, the supply conductor divided by 3, which gives us 32 amps. So we're looking at a number 8. So in here, I just want to make a note, it meets the ampacity for the motor FLCs under the continuous, and it also meets the calculated loads under table 27. So we go to our final variable here. This symbol here means to be interlocked. We're looking at the system, 3-phase, 600 volt. Our motor is a squirrel cage, wire is copper, non-time delay fuse, equipment is not marked. And here we're applying the same concepts. We have non-continuous, so we apply the table 27 value. This is also non-continuous, all regulated under subrule 2. So we're going to use our calculated values in here. Size our number 10 for our first two motors, number 8 for our second two. Now we deal with the supply conductor, 28108, 1B and 2. So subrule 2 is talking about the interlocking, where if one is not on, they are interlocked, so they're not running at the same time. So we only need to use the value of one of the motors, and that's what we see here. They're non-continuous, so we only apply the calculated values. 61.4, table 2 gives us a minimum of a number 4. So we're looking at here the maximum size non-time delay fuse, table 29. We're going to take 32 amps times 3, and again notice that we're using the FLCs for the fusing or for the overcurrent devices plus the 27 because we only need one of each. Gives us 123, and again that's a max. So we're looking at table 13, 110 amps. Now here's an interesting application. So we're looking at the tap conductor 28106 subrule 3. So we ended up with the number 4, 70 amps. So we take 70 amps divided by 3 gives us 23 amps, which gives us a number 10. Again, right, 60 degree column. So here it meets the ampacity for 23 amps, but it does not meet the ampacity for 38. Now notice that 28106 uses the language of not less. Therefore, we can install a number 8 for our tap conductors, and we'll be able to meet the requirements for that conductor. And that concludes our lesson on multi-motor circuits.